We got a list off. Yep. What we're looking at, we know how Venn diagrams work when they're overlapping like this. This little rectangle, square, whatever that is, the very center, the natural numbers. Those are the numbers that you start learning how to count with when you're 3. You know, you count 1, 2, 3, 4, 5. Those numbers are all positives. They're all whole. They don't have fractions or decimals in them. And they do not include 0. We haven't learned about 0 yet when we're just learning how to count. That's what makes up a natural number. That's its name. Okay? Okay, Rachel, Rachel's going to be the designated doorbell.
I'm so happy I'm not that anymore.
Hello. Then next rectangle around that, that's labeled whole numbers, that picked up the number 0. Okay? We think of whole numbers as something that's not a fraction or decimal, and that's still true. But what's also true about this label is that they're positive and it includes 0. So 0 is a whole number, but it's not in the natural numbers square. 3 is a natural number and a whole number. See how that's working? This is review stuff. I'm just maybe talking as we go. All right, then we get to integers. I like integers. What kinds of numbers got added to the integers? Negatives. Okay, so definition of an integer is a positive or a negative whole number. So just added negatives. If you're a negative whole number, you're in the integer space. Okay, so 3, is it a natural number? Yes. Is it a whole number? Yes. Is it an integer? Yes. It's in all of those. But negative 6 is not a whole number or a natural number. It's only an integer, right? Remember that stuff? And then the last one on this left side is rational numbers. See, those are hard to read, but those are just fractions up there. Rational number means you can be written as a fraction. 4/9, negative 5/8. How's a decimal a fraction? What's 0.6 repeating the same as in a fraction? It's a common one, y'all better know it. What's 0.6 repeating the same as?
2/3.
Good, same, 2/3. 0.6 repeating, which is what decimal same, 6 is keep going, it's the same as 2/3. So that's a fraction. What about this, 1.75? What's 0.75 as a fraction? That's an easy one. 3/4, right. 75 cents, you got 3/4. So those can be written as fractions. Rational number can be written as fraction. How is 2 a rational number? It's not a fraction. Can I make 2 a fraction? Yep. What do you got to do? Over 1. Y'all got it. Easy stuff. Come on now. This is easy. Y'all be answering quicker. All right. All that stuff overlapping here on the left side, but the stuff on the right side does not overlap. If you're in the left side, you cannot be in the right. Same thing with you're in the right, you cannot be in the left. And that ought to be obvious to you by what they're called. You cannot be rational and irrational. Those are opposites. So if you're rational, you can be a fraction. If you're irrational, you cannot be a fraction. So those are those ugly ones that keep going forever with no pattern. You know, like pi. Pi is an example of an irrational number. 3.141596. It keeps going forever with no pattern. Square roots that are not perfect squares. Square root of 15 is not a perfect square. That would be like 3 point, and it keeps going forever. Okay, those are your irrational numbers. People in first period wanted to argue about that one that I put, pi over 4. That's a fraction, it looks like. But pi is irrational, and when you try to divide an irrational number by something, it stays irrational. And that's what the over 4 means, divided by 4. Alright, so we got all that, all in the big category of real numbers. What kind of numbers are not real that we talked about in Algebra 2? Kids ain't there. Those imaginaries, it's the ones that got the eyes in them. We'll get into that later. We'll just keep it simple for a while, sticking with the reals. Okay?
Isn't that, I don't know, like when you say that, like I don't think that's like what you think, so. Well,
It's bad that you don't remember an imaginary number, yes.
what's an imaginary number?
Square root of -1 is I. We did that a lot in Algebra 2. You passed the test on it. Did you cheat?
Not all the time. Sometimes I got even tell.
Well, we'll get it. We'll get it. We'll get it. All right.
She got help.
They're throwing you under the bus now. You better hold on.
I didn't even have class with Chase.
No, you didn't. Chase was in a full one, I think. This in 6th period, 5th period didn't have very many in it. All right. So, I told you yesterday a lot of the stuff that we're going to be doing is just learning different ways of writing stuff. So this first thing, this says Setbuilder notation. Okay? So I'm going to give us an example of some Setbuilder notation here. Natural number greater than 12. That's a greater than sign. Let me read all this to you. First off, this thing on the end that looks like gibberish, that's supposed to be one of those braces. You know, those fancy parentheses with the pretty curves in them. That's what I'm going for there. So you can imagine that.
I can see it.
Thank you. Then this reads, and this is going to be new for us, how this reads. Anytime you've got one of those braces, that means you're dealing with a set. So since I see a brace there, I'm going to start by saying the set of all numbers, and it'll be whatever letters there. So this time we're using an X as our variable. So this will be the set of all numbers X. This straight line, I don't know who came up with this, but this is the rule. It reads such that, I spelled that wrong, P-H-A-T, such that, oh, I got worse the more I try to fix it. And then here's the meat of whatever you're talking about. So I would read this as the set of all numbers X such that X is a natural number greater than 12.
What's such that?
Because of, just like a, what would that English term be, like an interjection? Okay. So set of all numbers X such that X is a natural number greater than 12. Now that's called Setbuilder notation. These are some new fancy words, just get some new vocab out there. If I wanted to take this and list those numbers in the set, since it's a set, I would do a set. What natural numbers are greater than 12? So you got to know, remember on your Venn diagram what a natural number is. So tell me natural numbers that are greater than 12. What's the next natural number greater than 12? 13. Boy, that was a tough one. Next. Hey, now we're cooking. How far do I got to go? Say what, Willis? That's what I was hitting at. How far do I got to go? Keston said, wouldn't it go all the way up? So how far do I got to write them? I'm not going to stay here and write them all night. I got to practice some things to do in the house. There we go. Good. That infinite or that dot, dot, dot. I think that's an ellipse. Isn't that the grammar term? We talked about that. Dot, dot, dot. It's good with me. So, Setbuilder notation. And I told y'all yesterday that the college algebra had already had homework they were bringing in here for help. And one of them had an answer, and they get to do the odd ones, so they check their answers in the back of the book, but then they got to show their work. But they told me the answer in the back of the book said that. They didn't know what that meant. Well, it's too bad you're not in Algebra 3. We're going to learn that. So this answer in the back of the book that she didn't know what meant said that the answer can be the set of all numbers X, and X can be anything except 3, because it said not equal to 3. So you can play with that and read that different ways. Alright, so we can read and write in Setbuilder notation. So now we're going to go the other way. I'm going to give you the string of numbers here, and we're going to write it in Setbuilder. Are you ready? Mm-hmm. I got 1, 3, 5, 7, 9, and I have no dot, dot, dot. So that's just it. Those 5 numbers are in my set. And the directions say use Setbuilder notation to describe that. So if I got to use set builder notation, I know I'm going to start with something like this. So now I just got to fill in the rest. So first off, we got to decide what kind of numbers I got up there. Okay, I'm going to make a list over here on the side of stuff y'all say. I heard odd. I heard natural. Both of those are smaller than 10.
Greater than 0.
Greater than 0. Doesn't a natural number have to be greater than 0? Yes, so, but I like what Zane said. So if I wanted to use natural, I wouldn't have to include this. But if I wanted to use whole, I would include that. See how we float with that? Okay. Any other way we can describe those numbers? So to write this all fancified now, we got set of all numbers x such that x is an odd natural number less than 10. Does that get it? Yep. I think so. I think that's a pretty good description. Now you'll run into times when there's more than one way you can write it, and Zane showed us another way we could write this one. Another good way would have been x is an odd whole number less than 10 and greater than 0. So there's sometimes more than one way to skin a cat. Everybody good on that? Good? Grace? Glad you're participating there. Alright, we already did those kinds of numbers. That's you never heard that before, Kristen? Grace? Well, I said that. You remember that girl, Olivia McClure?
Yep.
I remember her from. I used that in her class one time, and she broke down and like started crying hysterically. And I was like, "What is wrong with you?" And come to find out, Hector Bellata had weed eaten her cat. Like the day before, and then I'm talking about skinning the cat, and Hector just weed eaten her cat. So, I kind of got touchy a little bit. But of course, Hector said, I didn't see it. I was weed eating the grass. I was like, shut up. All right, I got 3 numbers for you there. So we're going back to the Venn diagram that you copied a little bit ago. We're going to label those types of numbers that those are. Okay, I'm going to do the first 2 with you, and then you're going to do the third one with your table buddy. -7. Let's just go down the list. Start in that center of your Venn diagram. Is -7 a natural number? No. Keston's right, because it's negative. It can't be a natural number. Is -7 a whole number? No, because it's negative. We haven't picked up negatives yet. Is -7 an integer? Yes. So let's label this as an integer. Keep going out your Venn diagram now. Next is rational. Is that rational? Can I make it a fraction? Yes, I can put it over 1, so it is rational. Okay? If I'm rational, I know I can't be irrational, so I don't got to worry about that. On the very top of that whole Venn diagram was what? There was a big label, real. So this is also real good, Mason. All right, anything else with -7? Nope, so, oh, shoot. Let's scoot on, get off there. There we go. Let's scoot on to 3.14. Natural. Yes or no? No, naturals didn't have any decimals in it, did it? Whole? No. Integer? No. Rational? Yes. Because it's not the whole pie. It's just 3.14. 3.14 you can make a fraction because that's tens hundredths. You can put that over 100. 3 and 14 100ths, right? So if it had been the whole pie, keep going forever, it would be irrational, but it's not. So when the decimals terminate, when it's got a stopping spot, no dot, dot, dot after it or anything, it is rational. Okay? So that would make it real. Alright, the last one's square root of 4. It's intentionally a trick.
Aren't all the numbers real?
Today they are, but no, you just asked that question 5 minutes ago. What kind of number's not real?
Then it doesn't go number.
Oh,
Imaginary.
Imaginary.
It's the same thing.
Oh, Lord. Okay, square root of 4 is kind of a trick. So talk to somebody around you. I know y'all don't have a table, buddy, but talk to somebody around you and see if y'all can label square root of 4. You gotta do it toss the ball. What you got? All right.
Maybe. Right. Trying to.
Let's go to the Algebra.
Yeah, it is that, but it's more than that. Yes, so you're on the right level, yes. No, whole numbers are these in addition. So it's all the ones that are natural numbers, like 1, 2, 3, 4, 5. And then whole numbers is 1, 2, 3, 4, 5, and also 0. Yes. Because all this whole square is in that square.
Are we supposed to figure it out? 4?
0 can only be a whole number, it can't be in a English. Yes.
Are we supposed to solve the 4 and then figure it out?
That's the trick. Yes. Yes, and you don't need a calculator for that.
I know, us too.
Isn't it?
And it can even be more than that.
Supposed to be a line over the full page.
Yes, they got it. Oh, yeah, here it is, right? So it can also be.
I was like, those cards.
Yeah. All right. I'm on my way fixing this one. The third one's not right. Because turn it back over. What is the square root of 4? Okay, turn it back over. Which side of the 2 do you want? If you told me it's these things over here, it can't be over here.
Everything else is full?
Yep, everything else is good. And you need to add one more. Just one more on the left side, it'll fit it. Okay, got my new handy dandy way of picking on people.
I'm in.
Well, the dilemma is there's a lot more empty seats in here, so we'll just go generic. I need a 9 to tell me, E9. Kayla, tell me, Kayla's got this. Tell me one way I can classify that.
Natural.
It's a natural number. Good job. So we got natural. Now I need a 8. A black 8. I need a black 8. Who's a black 8? Brennan.
I don't know.
Brennan, I'm going to allow you 1, and this is it. So I hope this is when you really want to use it. I'm going to allow you 1 phone a friend. You want to use it now?
I don't know. I don't know.
You want to ask somebody else.
You got anybody in here you want to ask?
I don't know anybody's name.
How long
You don't know my name.
Nope.
Then shut up.
I really don't. I don't even know my teacher's names from last year.
Well, you better know mine because you're going to have me for the 3rd year. It's looking like.
You're dropping out?
So you're
Give me
dropping out.
who's the other black 8?
Who could have guessed?
It's right here.
I've got another black 8. I got a 7. There's not very many 7s. That might be it too. All right, 7, Rachel. Tell me something. Hold. Okay. I got a red 8. Michael said rational, and that's correct. Still got another one, I think. Oh, another 2 at least. How about a black jack?
Right here.
What you got, Zane?
Oh, we got it. National real.
Real. Good. I got one more, and it's going to be Dustin. He doesn't have a card, so Dustin, tell me one more.
I'm lost. I already named the ones that I had.
Look on the left side of your picture. What's the one on the left they hadn't made yet? Integer. Very good. Positive or negatives. That's where negatives get added, is in the integers, but they can still be positives. That's a good question that Dustin just brought up. Now, why is it all those when square root symbols are on the right side and irrational?
Because it made us solve.
Very good. That square root can be simplified. That's why I told you it was a trick. Okay? Good job on that. All right. Now, still got a few more things. Y'all are doing good. Hold on. We're going to talk about, I got a true false. Y'all simmer down. I got a true false similar to the bell ringer. Some integers are whole numbers. And I chose this one just to make sure we're still understanding those directions. That's a number symbol, not a hashtag. Some integers are whole numbers, and it's just true or false is what we're discussing here. So what do you think? Can some integers also be whole numbers?
Yes.
I like the answers I'm hearing so far. If we remember, we've got real, the big square, there's my real, and then I got rational, and then I got integers, and then I got whole numbers. So whole numbers are in the integer square, aren't they? So some integers are whole numbers. Now, is every integer a whole number? No, because an integer, like Dustin said a minute ago, can be negative, right? So a negative integer would not be a whole number, but a positive one would be. Okay? And those wordings on that sometimes play with our brains. They're sometimes confusing. Okay. Next thing we got to talk about, two definitions real quick. First one is called additive inverse, and then absolute value. All right, I'm going to give you some examples over there in the additive inverse side, and you're going to formulate the definition for me. So if I looked at the number 5, and I told you that the additive inverse of 5 is negative 5. Then I'm going to take the number negative 10. And I'm going to tell you that the additive inverse is 10. That's okay, good. Mason's got a good start for us. It's the opposite, right? 5 and negative 5 are opposites. Negative 10 and 10 are opposites, so I like that. The definition says additive inverse. So I'm thinking there might have to be something to go along with what Mason said that has something to do with this additive word. What do opposites add to?
0.
0. Very good. So our technical definition that Mason helped us find, additive inverses have a sum of 0. And yes, to get a sum of 0, it has to be just the opposite sign. 23 and negative 23. 79 and negative 79. Negative 98, positive 98. It's the opposite. Now put those both up here on the same additive inverse with absolute value, because believe it or not, people confuse those. Okay, I'm going to give us some examples. I'm going to say the absolute value, and remember those are the bars. Absolute value of 5 is 5. Absolute value of negative 5 is 5. Well, how can we write a definition of absolute value?
Always equal to positive.
Good, and especially in those examples that I have right there, it's equal to a positive. There's only, I'm not going to write that in my definition because there is one instance where it doesn't, and it doesn't happen very often. Only time you'll ever have an absolute value that's a negative is if they put the negative out in front like that. Because that means you would do the absolute value of 5 is 5, and then you would make it a negative. But that's the only instance where it's not what Mason said. But so what if you're? I am going to stick with this thought though. What is always positive? It sounds crazy. Okay, here's what I mean.
0.
No, 0's neutral. If I start walking this way, how far did I walk? A distance 15 feet? Pretend 15 feet? Okay. How far did I walk this time?
13 feet.
But I went backwards.
Negative.
It's still the same.
Good. No. Good. Even if I go backwards, I still went that same distance. Distance is always measured positive. And I tell this, and Mason's heard me say this before, if we go down to the shop to Coach Fulcher and tell him to cut me a negative 14-foot board, it's going to pick it up and hit you with it. There's no distance that's negative. You don't measure negative. Even if you drive your car backwards, you're still going somewhere. You can't take the miles off, right? So, absolute value definition, distance. Distance from what? You can say where you started, but that's on the number line, 0. Good, Mason. Distance from 0 on the number line. Okay, easy schmeezy on that. Okay, go ahead. Oh, thank you, glasses. Alright, I'm going to make a list of some different symbols that we're fixing to use just to make sure we know how to say them correctly, because y'all know I don't have a lot of pet peeves. I'm pretty laid back and relaxed. And one of the things that y'all do sometimes that drives me more nuts than anything is not knowing what these things are called. I get so aggravated at hearing about who an alligator is eating and which way the Pac-Man is going. We do not use those. Okay? This is a less than symbol. This is a greater than symbol. If you know this and can say it, you don't got to write it down. But if you say Pac-Man or alligator, that's no bueno. Somebody's printing the things out of paper. This is less than. What's the bar underneath it mean?
Equal to.
Very good. Less than or equal to. So this one will be greater than or equal to.
Put an E or
And what?
greater.
I think it's an E. Greater? I'm not real sure. I think it's an E. Oh, this, I see what you say there. My handwriting is bad. Yeah. Alright, then this one's a no-brainer there. That's an equal. Write it out that time. What about the equal with a slash through it? Not equal. I don't think you ever had problems with those. Well, good. I'm glad she's out of paper because she's the one that prints all the time. She's going to go get it herself. That was me.
Oh, I know.
I'm one to myself. There's when we share printers and there's one teacher that's constantly printing and it's out of paper. That's what I'm saying. All right, we ready to use some of those? We talked about set builder notation at the beginning. We're going to build on that. Everybody got what you need? Set builder notation is this. All numbers x such that x is greater than or equal to 0. What we're going to do with that is two things. We're going to take it and write it in interval notation, which is new. Haven't said that to you yet today. And we're also going to graph it. Okay, so we want to do those two things. That graph it, write it in interval notation. My personal preference, which my way is not better than anybody's way. You don't got to do things my way. Y'all know that. I never make y'all do it only one way. If you find a better way, let's do it a better way. But my personal preference is I'm going to graph it first. And these graphs, when it's just an X, are always on a number line. So I'm going to get my number line ready. I know I got a 0 over there in the problem, so I need to have a 0 on my number line. It's not a real written rule about what other numbers you need to put on there, like you go from 10 to negative 10, that kind of nonsense. I just always include one lower and one higher. So that's how I'm going to label mine. Okay, this tells me to graph everything that's greater than or equal to 0. Which way does greater than go on my number line? To the right. So we're going to shade everything to the right of 0, including our arrow. Now, when we were in Algebra 2, there were symbols that we would put on that. If it was greater than or equal to, we would color the circle in. If it was just greater than, we would leave the circle open. Y'all remember that? But we're going to learn new symbols this year in case we have a college algebra teacher that uses a different symbol. Since this has got a greater than equal to, since it's got the bar, it's going to be a bracket. So we're going to put a bracket on that. So if it's greater than or equal to, less than or equal to, you're going to put brackets. If it doesn't have the equal to, if it's just greater than or less than, it's going to be parentheses. Okay, that means the same thing as your open circles and empty circles used to mean. A bracket, it includes it, it can touch it. A parentheses, it does not touch it. It's open. It does not include it. Okay, so we've got our graph. The reason I like to do that first is because now when I go to interval form is kind of just like what an ordered pair would look like. So you're just going to read your graph left to right. And you say, well, it starts off right there with a bracket on 0. So I'm going to put a bracket and a 0. And then I'm going to put a comma, and I'm going to put how it ends. Well, this never ends. It keeps going to the right forever. So I need a symbol for that. Infinity, good grace, so I'm going to throw an infinity. To the right is positive infinity. To the left is negative infinity. Now, deep thought question, am I going to put a bracket or a parentheses on that infinity? Good, Baylor. Why?
I think it's because 0 is not a whole number and infinity is like all. Is that not what it is?
It's close. You're on an okay path. What were you going to try to help Keston? Right, bracket. Well, a bracket means it touches it. That's key. It can be that number. It touches that number. Tell me how you touch infinity. You can't, right? Because as soon as you think, oh, I'm here at the end, nope, you can go one more. So you can't touch infinity. You know, that's when I usually start singing MC Hammer songs. The first period threw stuff at me, so I don't want to do that again. Y'all know, but they threat. Rachel might really, she mean. Just kidding. All right, bracket, parentheses, new symbols. We're not doing open circle and circle. How's your college algebra teacher going to do it? I don't know. Every college algebra teacher is different. But now you see a different thing that means the same thing. So if they do it circle or open, you did that down to 2. If they do it bracket or parentheses, you did that down to 3. You've gotten more options. You're going to know more what they're talking about. Okay? Let's do another one. One more of those. I got, this one's going to be a double. Got a double waiting here. Set of all numbers x such that -4 is less than or equal to x is less than 2. Directions are the same. We want to write that interval form and we want to graph it. Now, before I graph it, I'm going to graph it again first. Before I graph it, where does the x lie in that mumbo jumbo that's written in relationship to the -4 and the 2? How would you describe the x? It's in between them. It's in the middle of them. So I need to have that in my brain already. Right now, this x is in between them. So when I start graphing this, I probably think my shading might also be good, Grace, thank you for helping. If my x is in between these dudes, when I start graphing them, my shading might also be in between, right? Grace was the only one that was reading what I was trying to throw down there. So, do I need to include every number from -4 to 2? Absolutely not. I like it, Chase. It's okay if you do, but I'm the easy way out on that. I got them there. And we already talked about, this tells me I'm worried about the stuff in between them, because this is in between them. So in between them is where I'm shading. That's what I'm fixing to ask you next. What kind of marks do we have to put on them? Because look up there in the Setbuilder notation, there's 2 different symbols up there. Okay, Chase said bracket on -4. Let's test that. -4's got an equal bar. Yes, it's going to be a bracket. Do I need to set it that way or that way? Top or bottom? Top. Top, good. It opens where your stuff is, right? So I would open it that way. Okay, now what about the 2? Does it have an equal bar? No, so that means I'm going to have a parentheses, and will I be top or bottom? Top, because it's going to open where the stuff is. Very good. Okay, good job. Good looking graph on that. Now all I got to do, and this is why I like doing the graph first, all I got to do to get that into interval notation is basically just rewrite it without the number line. So my interval notation would say, well, you got a bracket, you got a -4, then you go to 2 with a parentheses. So there's your interval notation. Not much to that. going to give you one of those to try. You can talk to your buddy if you need to. Then we got one more. We're almost done. Got one more thing after that. All right, I got set of all numbers x such that 0 is less than x is less than or equal to 3. All right, I need you to graph and write in interval form. Okay, get it done. Talk to your buddy. Check with your partner and make sure everybody got their symbols right. That's going to be 4. Come on, Grace. What do you think that says? Don't say it. I just don't say it. It says form, Grace. Form. You know whose mind's in the gutter in here?
I'm just ready for it. There's one to ruin it.
All right.
I did this one, so probably wrong, but I did it.
Put those like actually on numbers. Put the parentheses on a 0, the bracket on a 3, you know. But that's good. What we got, Mr. Dustin? Yeah, good job. Go. You got it. You got it. It's easy. All right, let's see, and then we'll do one last thing and close it up. Pretty simple. Get you a number line that includes the numbers from 0 to 3. No rocket science on that. What section am I going to shade in this stuff? In the middle. Now, have we ever, in Algebra 2 or in Algebra 1, have we ever graphed stuff that goes out on the sides? Yeah, we've done that before, but we're just not there today, so don't get bogged down and worried about that. We're in between them right now. I got bad scribbles.
It's basically going to be in between all the time.
On this, yes, you're right. All right, so what kind of mark goes on my 0? Parentheses, and what about the 3? Y'all got it. So then you just rewrite it. That's it. All right, last thing we got. I need you to get back in your classroom one last time. We're going to try this. I'm planning on doing it every day. I may get mad and not do it, but I've got an exit question typed up. I just got to hit post. It's a real easy one just to conclude the day up. Sometimes there'll be a grade, sometimes they won't. You won't know. $2.20. Yeah. I'm opening mine. Just give me a second. All right, I just posted it, so you might have to give it a second and try to refresh. There are 2 answers. It asks for 2 answers.